Our planet does not sit still. It is in a state of constant, gradual transformation. Over immense stretches of time, landscapes are born. They mature. They eventually wear away. Mountains rise toward the sky, then they are ground down. By wind, by rain. Seas advance. Seas retreat. They cover continents. They expose them once more. This process is far too slow for a single human lifetime to witness in its entirety. It is a geological ballet performed on a planetary stage. Each movement can span an era. To understand it, we study the rocks themselves. They hold the memory of ancient oceans and long-vanished mountain ranges, revealing how low basins can become high peaks over millions of years. Long before a mountain exists, a space must be made for it. This space begins as a geosyncline, a massive, slowly sinking basin. Imagine a long, shallow depression forming on the Earth's crust, often along the edge of a continent. This area sits lower than the surrounding land. It might be a shallow sea, or a broad coastal plain that is gradually subsiding. The formation of the basin is the critical first step, a vast receptacle waiting to be filled. Rivers supply the raw materials that will be transformed into rock and much later thrust into the sky. These great basins do not form by accident. They are created by the immense forces of plate tectonics. Where plates pull apart or bend downward, the crust can stretch and thin, and the surface sinks, producing a long trough-like geosyncline. It is a quiet, almost imperceptible process. Over millions of years, stable land becomes a depression, setting the stage for what follows. A newly formed geosyncline is often watery, a shallow inland sea, or a large gulf connected to the ocean. Rivers carry sand, silt, and clay into the low-lying area, beginning the long filling of the basin. Modern analogs show regions slowly subsiding under the weight of new sediment. Once the Great Basin has formed, the slow process of filling it begins. Rivers act as nature's conveyor belts, carrying tiny particles of rock and organic matter into the basin. As currents slow, sediments settle, sand near shore, mud farther out, clay in the deepest, calmest water. Relentless and continuous, layer upon layer, each recording conditions at the time of deposition. Thick sandstone marks powerful rivers, fine-grained shale records calmer waters, and fossil-rich limestone points to warm, clear, shallow seas. Over millions of years, these pages stack into a detailed geological record. Given time, sediments can reach astonishing thicknesses, sometimes miles deep. As they pile up, layers preserve snapshots of life, marine creatures, plants, and microfossils. Finding a sea fossil high in a mountain shows those rocks were once soft sediment on an ancient seabed. As layers accumulate, their immense weight makes the basin subside, creating more space for even more sediment. This self-perpetuating cycle allows extraordinary thicknesses to form. Burial pressure squeezes out water and compacts the sediment, the first step toward rock. With depth, heat rises and minerals reprecipitate as natural cements. Lithification turns sand to sandstone, mud to shale, shells to limestone. For millions of years, the layers lie relatively flat and undisturbed. But the calm does not last. The same forces that created the basin begin to push its edges together. Compression begins. The former zone of sinking and stretching turns into a zone of squeezing and shortening. Seemingly rigid rocks bend like a plastic material when stressed over vast timescales. The flat layers warp into waves, upward arches called anticlines and downward troughs called synclines. Folds range from inches to miles across. If pressure grows too great, rocks break along faults. Huge blocks can be pushed up and over others on thrust faults. Crust shortens dramatically, stacking layers like a messy pile of blankets. As the crust thickens, it floats higher on the mantle, like an iceberg, so the crumpled rock mass rises. This is the birth of a mountain range. Even as uplift continues, erosion immediately begins to sculpt peaks, ridges, gorges, and U-shaped valleys. The final landscape reflects a balance between upward push and downward carving. From seabed fossils to vast folded layers, the evidence of this journey is written across the mountains.